Good morning. We're going to give a shot here and see if we can teach a lesson using my little small whiteboard at home and the Zoom thing here. We'll see how this goes. So this particular lesson is on scatter plots and slopes. So you should have your books open to page 660. Remember, this is a video. You can stop it, pause it, back up, do whatever you need to. So I'm not going to worry so much about time. So we'll talk a little bit about scatter plots and slopes, and we'll look at the assignment, do some of it together, which you're kind of missing out on the videos, and then we'll go from there. So the scatter plot is basically the idea that in real life, things aren't typically linear or fit any other type of curve. It just doesn't work that way. And so in real life, data can be more scattered. That's why we call scatter plots. And the idea is to see if the data does seem to follow some pattern. In our particular case, we'll talk about linear equations, but scatter plots can also follow other patterns like parabolic or exponential, a lot of times exponential. You may have seen some of that stuff on the news. We're talking about the coronavirus. People have sometimes shown some stuff, their data is based on scatter plots. So the bottom line is, so you still draw horizontal and vertical axis. Typically, it's a quadrant one thing. In real life, most data is positive, although it's possible to have negative data. And sometimes the numbers start strangely. They don't necessarily go 0, 1, 2, 3. So sometimes to make your graph better, you sometimes need to do a little break in the graph. This little thing right here means like maybe this is 0, but maybe this starts at 50 and then it goes 60 or whatever, okay? Same thing down here. I can do the same thing here. I can put a little break here. I can start at 0, then start at some other number like 17, whatever, it doesn't matter, okay? So, and then this area will be accurate. I want my scatter plot to be accurate. So you take your data, you have X, Y coordinates, or whatever it is that you're talking about, and you plot the data, okay? You plot the points. And you try to decide if it creates some sort of pattern. So in this case, I have this point and this point that don't seem to fit the pattern. Those are called outliers. What you do with outliers is up to you, but you have to be careful. You have to realize that there's a reason why an outlier might exist, and that's reasonable. If you think it's reasonable, you can toss it out. For example, if we were doing a data point having something to do with everybody in our particular class and tied to ages, and obviously my age of 74 would be an outlier because everybody else is going to be somewhere around 14, 15, 16, 17, or 18, whatever. We'd be pretty close together. So that would make sense why that data would be thrown out. So then you look to see if this can create some sort of a line, okay? So what I'm looking for is called a line of best fit, okay? So this is a best fit line, okay? Best fit lines, call that because you look for the line that fits the data the best. So you just kind of draw what you think is roughly what might be a line that might go through your data, okay? It's going to be rough, and obviously everybody's not going to get the same answer with the same piece of data, okay? So that's my best fit line. And what I'm going to do is try to write an equation, typically called a regression equation, okay? So a regression equation. And by the way, your calculator will do this. You can use the stat part in a graphing calculator to enter data points, and it will give you a line of best fit. It won't draw a line, but it will give you a slope, and it'll give you a y-intercept, which is all we need. So that's what we need here. So in order to come up with a line, this is what you were doing in the last lesson, writing equations, then I need 2 points, okay? I need 2 points to find slope. So hence here, the points should be far apart. If the points are too close together, that can create problems. I'm looking for 2 points that are far apart. They don't have to be on the line, but they should be the same distance above or below the line. So for example, this point and this point are reasonably far apart, and they both are about the same distance below the line. So I could take those 2 points, plug them into my slope equation, which we'll talk about later, and find slope, okay? And then once I had slope, I could use some form of the equation to actually write my data, okay? So basically, we can either use y equals mx plus b, Let me do some erasing here. Pretty small space. We can use y equals mx plus b, and you found your slope, and you take the slope and one of the points, doesn't matter which one, plug it in for the x and y values and solve for b, and that gives you your equation. You can also use something called the point slope form. Y minus y sub 1 equals m times x minus x sub 1, plug in the slope, plug in the x and y values and solve for y, but it's really easier to do it this way, okay? As you guys already know, there are things I want you to learn, but a lot of times I'm about doing it the easiest way. So that would allow me to write my equation. That would be my prediction regression equation, also called a prediction equation, because the whole point behind the equation is to be able to predict data. I want to be able to predict if I have an x value, what's the y value. Now I say x and y, but remember in real life, in normal math, we talk about the independent variable, the dependent variable. This variable depends on this variable. In real life, we don't know typically what depends on what. So we just draw two axes, label them whatever they are, and go from there. And we're just looking for a relation, looking for a correlation. Okay? The magic word is correlation. We're looking for some sort of a correlation, right? Okay, so that's basically what we are. On the homework, you will have to do one of these, okay? That's all. And again, you can do it on graph paper, not do it on graph paper. That's up to you. All right. Just want to remind you that this is stuff you already have. You had this before junior high. And let's talk about some other data. Let's actually go to the homework, okay? So this is homework number 11. Okay, which is number 13 through 17, comma, we're going to skip 18, 19 through 23B, we're not going to do part C. And this is all on pages 663 and 664. Now, of course, this is listed in the Google Classroom on this assignment. It tells you this assignment is also in RenWeb, so nothing new there. All right, so pause or whatever, get your paper ready. Again, you can choose to do this on graph paper or not do this on graph paper. That's up to you. Parts of it will work out better on graph paper. I don't have a graph, but that would be okay. All right, I assume you've got this assignment written down by now. Pause to do that, and so I'll erase it. All right, so 13 through 17 says, determine whether the 3 points listed are collinear, okay? So we want to know if they are collinear. Are they collinear? Do they make a line? All right, again, two ways to do this. Three ways to do this, actually. You could graph the 3 points, all right? And that's pretty quick on graph paper. The problem with that is it's not super accurate, okay? Can you tell if 3 points are definitely not collinear? Sure, you can tell they're definitely not collinear. Can you tell they're definitely collinear? No, you can't. So this is not really the best method to do. It's a method of coming up with a quick answer, but it's not the best method. The second method, the one the book suggests, is you take the points and you take two of the points and you use those 2 points to write an equation, and then you plug in the third point and see if that works. And that'll work too. I'm going to show you the third method. Third method says if I have 3 points, I'm hoping that creates a line. Well, if I find the slope of this segment and find the slope of this segment, then if these slopes are equal, then all 3 points lie on the same line. If the points are not equal, then they don't lie on the same line. Pretty simple. So if they're equal, then you write yes, collinear. If they're not, you write no. So we're going to do 2 of these together, and then the others are yours. So let's look at 13, right? 13. So we have 3 points. We have points A, B, and C, okay? All right, so I'm going to find the slope of segment AB and find the slope of segment BC and see if they're the same, all right? All right, so remember the slope formula is the difference in y values or the difference in x values. So point A is 0 and 0, okay? So point A is 0 and 0, so X value, Y value. And then point B is 6 and 4. So 6 goes in the bottom, 4 goes on the top. And we'll use the same point down here, okay? And then point C is -3, -2, okay? So -3 goes in the bottom, -2 goes on top. All right, so 4 minus 6 is 4. 6 minus 0 is 6. That reduces to 2/3, okay? All right, a negative times a negative is a positive, so 4 plus 2 is 6. And the negative times negative is positive, 6 plus 3 is 9. 6 over 9 reduces to 2/3. So 2/3 equals 2/3. So you're right, yes, and you're done, but you got to show your work, okay? All right, so that's number 13. Again, I'm going to erase it because you can pause and write it down. And we'll do number 14 together, and then 15, 16, 17, those are all yours, okay? So we're doing 12 and 13, sorry. So that was not, I'm sorry, the first one we did was actually 11, okay? That was 11, this is 12, okay? So I wrote the assignment down wrong. Assignment is actually 11 through 17, go back and correct that, okay? 11 through 17, 19 through 23B. The first one we did was 11, this is number 12. I'm kind of working in the dark here, so. All right, so you're doing number 12 now. So you're going to do 13, 14, 15, and 16 on your own, okay? So for 13, we have points D, E, and F, okay? So for number 12, we're on number 12, find the slope of segment DE and the slope of segment EF. All right. So point D is 19 and -13. So this is 19 and -13. Point E is 14 and 18, and we'll put it 14, 18 here, okay? And point F is 10 and 10. So -13 minus 18 is -31. 19 minus 4 is 5. So I have -31 over 5. 10 minus 18 is -8. 10 minus 14 is -4. That is 2. And obviously 2 does not equal -31 over 5. So the answer is no. Okay. All right. So that's how you would do 11, 12, 13, 14, 15, 16, and 17. I'm sorry, yeah. 11, 12, 13, 14, 15, and 16. 17, we'll talk about now, and then 18, we're going to skip. All right, so 17 is your scatter plot problem. And look at the problem. It says the table at the right lists the United States birth rates. The rates are per 1,000 people living in the United States. We're going to draw a scatter plot to show how the year X and the birth rate Y are related. Okay, so I'll get you started here. Okay, so we're basically we have X, we have Y, and they tell us already. We don't have to decide. They tell us that X is the year. So this is the year, and this is the birth rate. Okay. And if you look at your data, if you look at your table, years go 1940 through 1990. So if this is 0, then I would stick in my little thing here. This would be 1940. Now do 1950, 1960, 1970, 1980, 1990, okay? And then the birth rate, you gotta look at your numbers there. The birth rates run between about 14, 15, 16, up to 20. So again, this is 0. I would make this like 14 or something. 15, whatever, okay? All right, so that gets you started. So you follow the directions, all right? And the directions say, draw a scatter plot to show that. So you plot your points, then write an equation that relates the year to the appropriate birth weight. So for part B, I want to see you take your straight edge. I don't want to see you, just take your straight edge. Draw your line, okay? Choose 2 points that are far apart and use those 2 points to find your slope, okay? And then once you found your slope, I didn't show you that at the beginning, then you pick a point on the line and plug that in. That's your point slope thing, and use that to find the y-intercept, okay? All right, that's part B, so that's a fair amount of work. Part C says, what does the slope tell you about the birth rate every 10 years? Well, your answer should be about it goes up, it goes down, it stays the same, or whatever, okay? Something like that. And then D says, predict the birth rate for 2000, okay? So what you do is you take your equation, plug in 2000 for X and see what you get for Y. That's pretty simple. And then it says, how reliable do you think your prediction is? You answer that, explain that. That's up to you, okay? That's on you. All right, we're skipping 18, and that takes us to 19. And here's where a graph would be useful, okay? I don't have one. I would, if we were at school, I'd do this on the board. But this is where the graph would be useful, but we don't have it, okay? So for 19 through 21, that goes together. It says the vertices of triangle ABC are given, all right? So vertices of triangle ABC are given. And we're going to graph those, okay? So the points, I'm going to pause here just for a second so I can get ready. All right, so again, you can be much more accurate. If I was doing this at school, I would be more accurate too, okay? All right, so X and Y. So point A is 2 and 18. So this is like 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Up somewhere right about here is point A, okay? Point B is -2 and -4, -2, 1, 2, 3, 4. Point B is here. Point C is 6 and 12, 3, 4, 5, 6. And 12 is up here someplace. My grandson's awake, okay? All right. So if you want to draw the triangle, this is my rough triangle, okay? Triangle ABC. All right, 19 says write the equation of the line containing the altitude of segment BC. Well, this is segment BC. So the altitude, the segment BC, would have to be perpendicular to BC, right? So I want to find the slope of segment BC. All right, so B, we said, was -2 and -4. And C, we said, was 6 and 12. So -4 minus 12 is -16. -2 minus 6 is -8. That equals 2. So the slope of segment BC is 2. So an altitude is perpendicular. Perpendicular, remember, is the opposite reciprocal. The reason we're doing this lesson is for algebra review, getting you guys ready for next year. So the opposite reciprocal of 2 would be -1/2, okay? So my equation has to be negative, my slope has to be -1/2. And it's 2 segment BC, so really we're looking for an altitude to segment BC, all right? So the altitude to segment BC has to actually be drawn this way, okay? So we need to use point A and that slope, okay? So y equals mx plus b. So point A was 2 and 18. You got y equals mx plus b. So y value is 12 equals -1/2 times 6 plus b. So 12 equals -3 plus b. So b equals 12 plus 3, which is 15, let's see. I'm sorry, A was 18, sorry. A was 2 and 18. I wrote down the wrong point. Get to see me make my mistakes here. Okay, so we'll get to do this again. 1A was 2 and 18. So this is 18, negative 1/2 times 2 plus B. So 18 equals negative 1 plus B, add 1, B equals 19. So my equation is y equals negative 1/2 x plus 19 is the equation for the altitude of segment BC. All right. Okay, so you should be able to get all that written down. I'm going to erase and you guys can pause. You knew I was going to make mistakes. All right, so that was number 20. 19. 20 says write the equation of the line containing perpendicular bisector of segment BC. Well, perpendicular bisector has to be through the midpoint, and it also has to be perpendicular. Well, we already know that. The slope is the same slope. The slope is still going to have to be negative 1/2, all right? So we have to go through this point too, which is the midpoint of segment BC. So I want to find the midpoint of segment BC, add the x values, divide by 2, add the y values, and divide by 2. Let me make some more room here. So slope of segment BC, add the x values, divide by 2, add the y values, divide by 2. So for BC, we had negative 2 and negative 4. So that's negative 2, negative 4. C was 6 and 12. So 6 minus 2 is 4. Divide by 2 is 2. 12 minus 4 is 8. Divide by 2 is 4. So the point is 2 and 4. So we're going to use y equals mx plus b again. 4 equals negative 1/2 times 2 plus b. Well, half of 2 is 1, of course. Add 1 to both sides. 4 plus 1 is 5. So I have y equals negative 1/2 x plus 5 is the equation of the line that is the perpendicular bisector. Okay. All right. Email me your questions. All right. So y'all should have time to pause, get all that written down. I'm going to erase again. All right, 21 says write the equation of the line containing the median from point A to point BC. Okay, so the median goes from here to the midpoint. All right, so we already know the midpoint. We found the midpoint in the previous problem there. Okay, and so we were using that midpoint. I remember the midpoint was 2 and 4, and point A is 2 and 18. And so we want to find the equation. Well, this is 2 and this is 2, right? Which means my line is vertical. That means I have a vertical line, okay? So that has to be x equals 2. That was pretty simple, okay? Has to be x equals 2. That is the equation of the line containing the median from point A to point B. All right, get that down. I'm going to erase again. We got one more problem to do. Okay. And the next problem, 2 more problems actually. All right, the next problems are different points. Okay. So 22 gives you triangle RST. All right, point R is negative 2 and 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously not very accurate. You can be more accurate. Negative 10 and 2, 1, 2. So this is point R is right here someplace. Point S is -2 and -4. So point S is down here someplace. And point T is -3 and 3. So look, something like that, okay? Find the equation of the altitude to segment RS and the median, and what conclusion can you make? All right, so we're going to find the altitude to RS, so that would be this segment right here, has to be perpendicular. All right, and so we're going to find the slope of segment RS. What R we said was -10 and 2, and point S was -2 and -4. So negative times a negative is a positive. 2 plus 4 is 6. And negative times a negative is a positive. -10 plus 2 is -8. That reduces to -3/4. Okay. So if that's -3/4, then the altitude is perpendicular. So the slope would have to be the opposite reciprocal, which is +4/3. Okay. And we're using point T. So point T was -3 and 3. So it's 3 equals 4/3 times -3 plus B. So this reduces. So this is -4 plus B. So if I add 4 to both sides, then B equals 7. So my equation is Y equals 4/3 X plus 7 is the equation for the altitude. All right, now we'll find the median. Well, the median goes from here to the midpoint. So that means we got to find the midpoint of segment RS. So I'm going to erase some of what I did. Again, you can pause. All right, so I need the midpoint of segment RS. Again, add the x's, divide by 2, add the y's, divide by 2. All right, so point R was -10 and 2, so -10 and 2. And point S was -2 and -4. All right, so -10 minus 2 is -12. Divided by 2 is -6. 2 minus 4 is -2. Divided by 2 is -1. So -6 and -1 should be the midpoint, all right? So that means from here to here, we need to find that slope, okay? So we have -6 and -1, and point T was -3 and -4. So negative times a negative is a positive. 4 minus 1 is 3. And negative times a negative is a positive. -6 minus 3 is -3. All right, I see my mistake. Let's go back here. We all make mistakes. Okay, so let's try this again. -6, -1. And it was -3 and +3. I was reading the wrong thing. -1 minus 3 is -4. Negative times a negative is positive. -6 plus 3 is -3. And negative divided by negative is a positive. So this is 4/3, okay? Which is the same slope we got for this, okay? So we have the same slope starting at the same point, right? So you have to end up at the same point, which means the equation of the median has to be the same equation. We could plug in the numbers, but I know if it starts here, it's got the same slope, it's got to end up at the same place. So therefore, they're the same. So if they're the same, then that means what? And that means that this equation, this has to be an isosceles triangle, okay? That's my conclusion. This has to be an isosceles triangle. These are congruent. This is congruent. So that means this is an isosceles triangle. So that would be the conclusion that I would draw. Okay? All right. Sorry about the mistakes. Okay. All right. Let's get ready for 23. And you'll just have a few problems to go back and do on your own. And so it'll be just like old time. All right, 23, we have another equation. All right, point A is -4, -6. So point A is down here someplace. Point B is -2 and 8. -2 and 1, 2, 3, 4, 5, 6, 7, 8. So up here someplace. And then point C is 6 and 4. And 4. So point C is here. So my equation looks something like that, okay? All right, so let's write the equation of the line through point D and point E, which the midpoints of segment AB and segment BC respectively. All right? So this is point D is the midpoint and point E is the midpoint, okay? All right, so that means I need to find the midpoint of segment AB and the midpoint of segment AC, okay? All right. All right, so point A was -4, -6. So -4, -6, -4, -6. Point B was -2 and 8. So -4 minus 2 is -6, divided by 2 is -3. 8 minus 6 is 2, divided by 2 is 1. So this midpoint is -3, 1 down here. Point C was 6 and 4. 6 minus 4 is 2, divided by 2 is 1. -6 plus 4 is -2, divided by 2 is -1, right? So this would be 1 and -1, okay? My drawing is obviously a little off. And this would be -3 and +1, okay? All right, so we're going to find the equation through those 2 points. So again, we need to find the slope of segment DE, right? So point D was -3 and 1, and point E was 1 and -1, okay? Negative times a negative is a positive. 1 plus 1 is 2. -3 minus 1 is -4. That gives me -1/2. So my slope is -1/2. To write the equation, I need to do some plugging in. So let's do some erasing while you're getting caught up. Pause, whatever you need to do. All right, so let's do, it doesn't matter. Let's do point E, 1 -1. All right, so -1 equals -1/2 times 1 plus B. All right, so this is obviously -1/2. Add 1/2 to -1, that's -1/2 equals B. So my equation is y equals -1/2 x minus 1/2. All right, that's my equation for that line, okay? All right. Part B says, what is it? So this is my equation for part A. B says, what is the relationship between the line through DE and the line through BC? Explain your reason, okay? All right. So this is the midpoint. So this is congruent to this, right? And this is congruent to this. So if you remember, basically, that means that this big equation and this little equation have to be similar, okay? They have to be similar equations. And essentially that means that this distance right here, length DE, has to be equal to 1/2 of length BC, okay? Because of that's, we learned that earlier, okay? All right, there's some other things you could say, but we'll make that satisfactory. All right, this is the end of what we're going to do. So you've got to go back and do, make sure you number 11, 12 correctly. Sorry about that. Do 13, 14, 15, and 16 together, and you can turn this side when you're done. So we'll try this again sometime. Have a great day.